Morning, everybody. Welcome back to the New England Aquarium for another Facebook Live. My name is Nick, and this is Taylor.
I'm Taylor.
Sorry, I interrupted her already. You'd think we'd never done this before. What's going on? Anyway, we're both very excited to be here with all of you for another virtual visit into some of the cool things that are happening here. Hopefully, at this point, you may have thought about or even had an in-person visit, but we definitely encourage that as well. The aquarium is open, so please come back and see us in person. But we also wanted to continue bringing some cool stuff to all of you virtually as well. And so today we're actually hanging out in a part of the building that during our reopening period is not actually open. This is our Science of Sharks exhibit, right, Taylor?
Sure is.
And it's kind of quiet down here right now, which is good for our purposes. We've got a beautiful tank as a backdrop. We have some adult sharks behind us that have actually just been fed, so you might see some cool action going on behind us here. What we want to talk to you guys about today is an amazing thing about sharks, and there are so many amazing things about sharks.
It's true.
It's their sixth sense. That's right, their sixth sense. And Taylor's going to start us off by giving a little bit of an introduction as to exactly what a shark's sixth sense is.
And it's a bit of a tongue twister as well.
It is.
Yeah.
Yes, I had trouble with that one.
So, just like humans, sharks have the same five senses that we do. They can see things in their environment, they can smell things in their environment, they can touch things, they can hear things, and they can taste things, but they also have an additional sense that helps them navigate their environment and more particularly helps them to find prey items. So oftentimes, especially sharks like the ones you're seeing behind us, are eating things that hide in the sand. Epaulet sharks, for example, are going to be eating things like shellfish and crustaceans, animals that burrow underneath the sand. So they might not be able to see them or smell them or hear them, but they use this other sense to be able to find their food. And this sixth sense is something called electroreception, which essentially means that these sharks can feel the electric impulses from the muscle movements of other animals. And you might be thinking, well, if they're resting in the sand, how are their muscles moving? Well, if you think about it, we have one really big muscle that is always, always, always moving, and that's your heart. So when these animals move their muscles in any way, shape, or form, you'll create a little bit of electricity with your muscles, which is something that maybe people didn't know, which I think is pretty cool. And sharks have special organs that Nick's going to talk about in just a minute that allows them to feel those electric impulses and find their prey. I think sharks are an amazing example of really fine-tuned evolution. They are truly designed to be top predators in their environment. And this includes all of their senses. They have really acute sense of sight and smell. They can hear things really efficiently. And then they have that additional sense that helps them locating and hunting down their prey. And this is for all different species of sharks. Now, sharks are not the only animals that have electroreception. There's a few other types of fish that have it as well. But they typically use their electroreception for something a little bit different, often for communication purposes, actually. And there's different types of sensory organs that help different species of fish do this. And they're all kind of a variation on something that all fish have, which is something called a lateral line. So if you look carefully at a fish, you might notice a line down the middle of their body. And what that is actually a series of pores. But the difference between a lateral line and the shark's electroreception organs is that a lateral line is more for feeling water movement. And sharks have these as well. This helps them feel water displacement around their bodies and sends a signal to their brain. And that's actually how schooling fish can swim together in a big group without being bumper cars all the time. So a shark's electrosensory organ is kind of like a souped up version of the lateral line. And they use this not only for finding food, but they think that sharks can also sense electromagnetic lines in the earth. So there's magnetic lines that go all around our planet, and scientists theorize that sharks can use those electromagnetic fields in order to migrate and to home in on their habitats, which I think is also pretty cool. So now that we've talked a little bit about electroreception and how sharks use that electroreception, let's talk about what it is that they have in their bodies to be able to use this sixth sense. And I'll turn it over to Nick to explain that.
Thank you, Taylor. Yeah, that was awesome. And you guys can't really tell, but we're both smiling right now because sharks are the coolest things.
They're really cool.
They're so amazing, yeah. So in order to talk a little bit more about what the actual organ is on the sharks, like Taylor was describing, I'm going to use some props here. I'm going to pull them over in front of the camera, and Marissa, who is operating our camera today, is going to help us out. Hold, please. Forgot one thing. Okay, I'm back.
You forgot a shark.
I forgot a shark, yeah. Okay, so they have this electroreception ability, and they use an organ that's called the ampullae of Lorenzini. And this is an image of a tiger shark, and we're looking at the underside of the tiger shark's head. That was hard to say, tiger shark's head. And if you look very closely, you might be able to see these tiny, tiny little pores. And these pores are connected to these jelly-filled canals that travel deeper into the shark's head and end in basically an ampullae-shaped organ that is also filled with this highly conductive jelly. Jelly is very good at conducting electricity. And there's also nerve cells that are connected to these ampullae as well that can transmit signals to the brain. And so basically, these sharks are putting these organs, these pores, and their ampullae of Lorenzini close to the prey items because they're sensing the electricity these prey items are putting off. It's pretty amazing. Stefano Lorenzini, the scientist, the researcher who actually discovered these organs in sharks, didn't really know what their purpose was at first, and so there had to be some additional research to figure things out. But he discovered them. He actually thought that they were more closely related to what Taylor was just talking about, their lateral line and their ability to sense vibrations in the water. But instead, these pores are able to detect very minute changes in the electrical field. And it's pretty amazing. In order to demonstrate this, I have an activity here that we're going to use. This is our bonnethead shark. Our bonnethead shark is going to do some hunting along the bottom of the ocean, looking for some of its favorite prey items, which include things like crabs. Now, you can imagine a shark swimming across the bottom. Very often they move in kind of an S-shaped pattern because that gives them the ability to sort of sweep a wide area. Another way to think about a shark swimming around like this is somebody that might be using a metal detector on the beach, looking for things in the sand. And so we've got our replica beach here. We're going to take our bonnethead for a swim, and it's going to use its ampullae of Lorenzini to see if it can detect any prey items. I'm going to make it extra dramatic here. It's coming around here. Oh, it's found a crab in the sand. Look at that. As it keeps on swimming, it can home in on other things, like an octopus, or it can home in on other prey items. Trust me, there are more in here, like a stingray. That's right, some sharks eat stingrays, believe it or not.
Particularly hammerheads.
That's right, yeah. So you guys get the idea. Now, you might think that what's happening based on this activity is that the prey is actually getting attracted to the shark. That's not really what's going on. This is just sort of to demonstrate that they use this ability similar to the way we use magnets in this activity to actually hone in on prey items and get really closer and have themselves a meal. So it's a pretty amazing ability. It's very fine-tuned like we've been talking about. And it's just one of those amazing senses that allows sharks to be such highly evolved predators, right, Taylor?
Absolutely.
Yeah.
I think another really cool fact in particular about hammerhead species is that scientists believe that their heads are kind of wide and flattened like that because they do search for so many prey items that live in the sand. And by having that flattened, elongated head, it actually spreads out that surface area and allows them to kind of spread out those ampullae of Lorenzini in order to more efficiently find things specifically living in the sand.
That's a good point.
Which
Absolutely.
I think is pretty cool.
Yeah. Okay, so the next thing we're going to talk about now is some of the challenges that sharks are facing as it relates to their survival in the ocean. Take it away, Taylor.
So one of the major challenges that sharks run into in the ocean is a man-made problem. So sharks share their habitat with a lot of things that we as humans also like to eat. So sharks often will accidentally end up as something called bycatch. Bycatch is any animal that's caught in a fishing net or on a fishing line that is not the intended catch. And if you think about, if you've ever been out fishing, you're probably hoping to catch one specific type of fish, but it's definitely likely that you've caught in a few things that were not the fish that you were trying to catch. And so that's kind of what happens with bycatch. But if you scale it up to a commercial level, now we're talking about catching a lot of things that we're not trying to catch. Now, the reason that this is such a problem for sharks is that sharks tend to get more stressed in a bycatch scenario than other animals that end up in those fishing nets. So their stress levels go up exponentially, and they have a much harder time recovering, even if the fisherman finds them with enough time to release them and let them go. Probably part of the reason for this is that, as you know, there are shark species that have to be actively moving in order to breathe. Some sharks rely on this thing called ram force ventilation, which essentially means that they swim with their mouths open and it pushes water through their gills. And that water movement over their gills is what allows them to breathe. Not all sharks have that, but those big open ocean pelagic species, think like great white sharks or hammerhead sharks,
tiger sharks,
yeah. Absolutely, are all species that rely on this. So if they get caught in a fishing net or hooked on something called a long line, then they stop moving and they have a hard time breathing and it becomes problematic. A lot of times they'll also fight and struggle if they get caught in a fishing net, and again, that requires a lot of energy in the moment and makes them more susceptible to danger after release. So one of the things that we can do in order to help out sharks is to think about how they get caught in these fishing nets. Another big problem for sharks when it comes to bycatch is that sharks are pretty long-lived fish. They're pretty long-lived animals, which means it takes them longer to reach reproductive age. And if they get caught in a fishing net before they have a chance to reproduce, then they're not replacing themselves in the ecosystem. And this can really lead to a steep decline in their populations. And we've actually seen that with certain species of sharks, ones that are susceptible to being bycatch, their populations have declined as much as 95%. So one of the things that we can do as scientists is to figure out how sharks sense their world and to use that in order to help sharks. So I think that's what Nick's going to talk about next, in particular related to their electroreception.
Absolutely. Thank you, Taylor. Yeah. And I think one of the great things, too, Taylor was using the word we, talking about trying to understand these things about sharks. That was on purpose because we do have scientists that work here at the aquarium that participate in a lot of this research to study stress levels of fish and sharks after being caught by recreational or commercial fishermen, try to figure out what can we do to help reduce the stress in these animals and reduce any mortality after these animals are re-released. So I think it's really cool that we're involved in all this research as well. Okay, so I have another graphic that I'm going to ask Marissa, our trusty camera person, to zoom in a little bit on here. We're going to talk about some technology that researchers are studying to kind of utilize the knowledge that Taylor and I have been talking about as it relates to sharks and their sixth sense. So if they have the ability to hone in on these electrical currents that are being produced by animals moving their muscles and their hearts beating, well, I wonder if there's something that we can do to repel them from these things. And by repel, I don't mean physically push away, but sort of discourage sharks from getting close to things. One of the first things that scientists have looked at is magnets. So magnets certainly disrupt the electrical field around them. And using magnets, scientists have been able to actually show some preliminary research that says that magnets may actually help to sort of confuse the shark's ampullae of Lorenzini and cause them to sort of swim away or avoid the source. So scientists have taken a look at the possibility of producing hooks using highly conductive metal as well as attaching a magnet to the hooks in addition to that. And this is one particular company. This is not an advertisement for that company, but this is one particular company that studied this prototype to see if it would work. There's definitely some promise here. I think one of the challenges is that Taylor was mentioning some of the fishing methods that we use. Long lines use hundreds of hooks, and so we would have to outfit each one of those hooks with this specialized hook. That could be kind of pricey. Hopefully we'll be able to figure out ways to bring the price down for things like that. Another idea is to take a look at increasing the intensity of an electrical field to kind of overload a shark's ampullae of Lorenzini. So this is actually a net that we're calling here a shark repellent net that basically has an electric motor on it that's producing an intensified field around the mouth of the net. So as the net is sort of dragging across the bottom of the ocean, if it comes near a shark's ampullae of Lorenzini are going to become overloaded with that electrical signal, and they're actually going to swim away. And so these are technologies that definitely have some promise. They need to be further studied. I'm sure that you guys have probably read about some other technologies. I just had someone tell me the other day, Taylor, about a study that's going on, I think in Australia, where they're using artificial kelp beds and putting electrodes in the kelp beds to send off a large electrical signal that is actually discouraging sharks away from areas where surfers and beachgoers like to hang out. So there's a lot of research going on to try to figure out if there are ways that we can sort of take advantage of this knowledge that we've gained about sharks and their electroreception. This is the part of our presentation where I say science is really important, Taylor.
It sure is, Nick.
Because we wouldn't know about how to address problems such as bycatch with sharks if we didn't have an understanding of their electroreception and how their ampullae of Lorenzini work. So it's really important to support the research that is finding out all these things about animals that live in the ocean, because it's helping us and will continue to hopefully help us to protect them as well. And sharks, as you probably heard Taylor and I say before, and many other educators here at the aquarium, they're such an important part of a healthy ocean. So we want them to be around. We need them to be around, in fact.
Absolutely.
Okay.
I think this is the part of our presentation when we open up the floor to questions from all of our viewers this morning. So hopefully we have a few questions out there at this point. Marissa, are you seeing anything?
I don't have anything yet.
You guys still drinking your coffee? Gotta get up. Here we go. Let's go.
We have changed the time on them, Nick, so they gotta adjust to this earlier hour, kind of like you and I with the building opening earlier than we're used to.
That's fair. That's definitely fair. Absolutely.
Well,
let's see. We can talk about some of the things going on here at the aquarium related to sharks, Taylor.
Absolutely. I actually do want to mention that the next time you come and visit us, if you take a careful look at the animals in our Shark and Ray touch tank, you might actually be able to see some of these little pore-like structures that we were mentioning. So you can see their ampullae of Lorenzini, or things like their lateral line. There's little like pores all in a row, and you can see the little designs on their heads and underneath their noses if you look really carefully at some of our sharks when you come to visit us here at the aquarium. So just a cool tip for something to look for next time you visit us.
That's actually a really good point. I know when I look at the cow nose rays, Taylor,
yeah,
I can really see the lateral line well on the top of their head. But if you get a look through the glass or even underneath the animal, then you can see the ampullae of Lorenzini, like Taylor was just talking about as well. Yeah.
I do have one question.
Okay.
Do all sharks have this sixth sense?
Do all sharks have this sixth sense? That's a great question. Nick, do you want to take that one?
I sure do, yeah. So to my knowledge, I believe all sharks have the ability to use electroreception and have these ampullae of Lorenzini. Even some ancient species like chimera or ratfish have the ability to use electroreception. Like Taylor was mentioning earlier, it certainly exists in other animals as well, and they use it for other purposes. But in cartilaginous fish, in sharks, rays, skates, sawfish, all of these fish use their electroreception primarily for hunting purposes. So, great question, yeah.
I was actually reading an article in preparation for our presentation this morning, and there are scientists looking at prehistoric sharks and doing 3D scans of their fossils to determine whether or not prehistoric sharks and fish had these ampullae of Lorenzini, and it turns out they did. So they're now actually studying the evolution of electroreception in prehistoric fish species, including sharks, which I think is pretty cool.
That's just a casual morning read for Taylor and I, while we're eating some breakfast. No big deal. That's awesome. That's really cool.
Yeah.
Do we have any other questions?
Rays also have this sixth sense?
Great question.
Yeah, sure.
So yes, sharks and rays are closely related and share many commonalities, including their cartilaginous skeletons and this sixth sense, their ability to do electroreception. And in fact, if you watch our stingrays upstairs in the shark and ray touch tank, our countless rays have these specialized fins that they can actually lower to the sand to get those ampullae really, really close to the sand when they're hunting for food, which is pretty cool.
I'm going to throw this out there, and I may have some people correcting me on this, but
oh boy.
My feeling, I know, I'm preparing Taylor for this. My feeling is that animals like rays tend to be more demersal, live along the bottom of the ocean, whereas there are plenty of shark species that are more pelagic, live up in the water column or in open water. And so you can imagine for an animal like a ray that spends more time along the bottom, hunting for prey items might involve looking for things that are burying themselves in, or buried in the sand. And so having this ability to sense electrical currents of animal movements is extra important for rays while they're hunting for their food. How do we feel about that statement?
I would not disagree with it.
All right, good.
One more question. Do any animals have a defense to this sense?
Do any animals have a defense
What a
to
good
electroreception? Wow.
Like a shield or like a way to reduce their electrical output? I didn't read any articles about that this morning, I can tell you that much.
Yeah, no, I haven't heard of any animals doing that.
I haven't either.
I'm not sure that there is a defense against this sense. I think they just have to be really efficient hiders and hope that they don't cross a shark.
That's what I was going to say too, actually, is maybe they bury themselves deeper, but...
Or make a quick getaway.
Yeah, or make a quick getaway. But that's a great thought, and definitely something that gives fodder to more research to understand if animals have the ability to sort of reduce their electrical output to avoid being captured. Yeah. Okay.
Awesome. Well, my friends, thank you so much for joining us again this morning. Stay tuned on Fridays. We're going to try to come to you live every Friday. So get your coffee, get your morning cereal in.
Get your research papers ready.
Those
right?
Wheaties, get the brain going.
That's right.
Bring your questions because we love answering questions for you. Thank you for joining us this morning from our Science of Sharks exhibit. We hope to see you back here again soon.
Bye, everybody.
Thanks.